So, continuing where we left off in the last video, I said we would look at some slave clocks, and that's exactly what I have right here. I have already hooked it up to my master clock via this wire here, as you saw, so it's all running. Now, this is another Soviet clock, once again, made by the Strela company. Well, Strela means arrow. This was from the 1980s. And the name for this one, the model name, is ЭВЧС-24, which translates, well, it's an abbreviation that translates into electrical slave signal clock. If you open it up, look on the inside, well, first of all, we have the manual for the clock, where you can also see the name, and it has there's an interesting illustration here where you have a ship and a locomotive. I'm not sure what, if that is, something that will, like if this was used to any extent in the transportation sector. Maybe it was. Not entirely sure, but we do have, once again, how to use it, how to store it, troubleshooting, and here is the certificate and the stamp that this is, a working clock. Another thing is, that's included are 2 additional fuses for the signal part of the clock, and also what is supposed to be a screwdriver. Not sure how useful this one is, because it doesn't really have a handle. So looking inside the clock here, you can see there are 2 distinct parts. The first one is right here, which is of course the clock movement, with the big code or data wheel that you have right here. And then on this side right here you have the signaling relay and the fuses. And this is actually what's going to be then sending the signals out to whatever you have hooked up to it. So looking at the movement, there's nothing really complicated here. So the movement itself consists of basically 2 coils, one here and one there, which move this arm. Every time an impulse is sent, as you just saw, the arm will swivel over to the other coil. This is basically a stepper motor in a way, as this arm then, via a ratchet, moves a wheel here. I'm not sure how well you can see it, but it's right here behind is the wheel that then moves the minute hand. The minute hand, and then via this gear reduction that you can see here, then drives the hour hand of the clock. And that's basically the entire movement. That's actually pretty simple. Now on the signaling side over here, you have this wheel right here. That's what's being driven by the stepper motor right here. This is a minute wheel. This then drives, via the cogs here, this big signaling wheel that you see right here. This one has a bunch of numbers etched into it, as you can see. So you have 23, 22, 21, and so on. And it goes all the way, starting over here at 1 and all the way to 24. Every 5 minutes, you have a hole drilled into it with threads. There's about 10 minutes between each hole here, and then 10 minutes between each hole here, and then this is shifted 5 minutes to this. So every 5 minutes you can put one of these pins in. Now these pins are removable. There is a total of 50 pins, I think. Now these are removable and you can put them just as you want, and that is what programs basically when this clock will send a signal. As these pins go around, they will close this set of contacts right on the back side of the wheel here. So each pin has its own set of contacts right here. See if I can focus. So you can see there. So the pins will actually close these contacts here. And as you can see, they're moving back and forth like this. And that closes them right between here, which completes the part of the signaling circuit. But because this wheel moves very slowly, and it is very difficult to make, a solution to only have these contacts here closed for that specific minute. So this is actually pretty inaccurate. So what they've done is on the minute wheel here, you have these pegs that stick out, this little cogs. What these do is, you see this little arm with the hook over here. Now, every time a new signal comes, it will push this arm and close this contact right here. Now, since this wheel makes one step every minute, the next signal is going to then push this arm off the peg and release these contacts over here once again, which means that now the circuit will only be complete precisely for 1 minute at the minute mark. So at 5 minutes, at 10 minutes past, at 15 minutes past, and so on. So that helps to solve the accuracy problem right here. There is another wheel though, which is this wheel right here that handles this contact, that has 7 holes in it, and this is the week wheel. Makes 1 turn every week, and it is, for example, if you want to have your signals go out Monday to Friday, for example, but Saturday and Sunday, when let's say nobody's at work, you don't need the signals, so you can just put pins in here and prevent signals from going out. So that's basically the difference between this wheel and this wheel, is that here you put in pins to make something happen, while here you put in pins to prevent something from happening. And now if all of these 3 contacts are closed, it will then, via these red wires, send a signal to this relay that is in under this plastic cover. Let me see if I can open it up. So right in here you have a relay with 2 sets of contacts. One is normally closed and one is normally open. And then when this relay activates, yeah, as you can see, it draws the contacts together. Then down here you just have fuse holders and some filter caps, I'm guessing. Now there is, however, another set of contacts which is right over here that also need to be closed for the relay to trigger. And that is a thermal relay, or a thermal contact, I guess you can say. The reason for that is that, since this movement here closes the contacts for an entire minute, but you may not always want a signal to go out for an entire minute. Let's say you have this thing connected to a bell. Maybe you don't want the bell to ring for an entire minute. And that's where you have this thermal relay. So using this adjustment screw on the side, you can set for how long you want this relay to be closed. I think the lowest time is like 7 or 8 seconds or something like that. So basically that will let you kind of have control over, how long your signal is going to be going out. And then you have 2 terminals here. So this terminal right here is basically where you connect the signal from the master clock, which is what I've done through this cable. And these contacts down here are what you use to connect the, your bell system or whatever. Now, because usually if you have like a bell system here, it's going to run on, let's say, 120 volts maybe, or 220 volts, like, or 230 volts like it is in the grid. You have all this exposed wiring here. It's going to be a little dangerous. So what they have done is actually put a safety feature down here. You have two contacts, and those contacts will hit this little metal plate on the front cover here on the clock, and when it opens, these contacts will also open, and there is one contact for the neutral and one for the live wire that you have going in here, which means that they will disconnect any voltage present on this board, so it is going to be completely safe to touch. So yeah, and then on top of the clock right here, we have this button which you can use to operate this relay directly. Let's say you need to manually send a signal. That's what you can do using this button right here. So yeah, that's about it. I want to see now if I can maybe hook it up to my master clock here and put everything up on the wall. I'm thinking right here maybe. And we'll see if maybe we can hook something up to the signal output on this thing and see if that part works. We'll see when it's done. There we go. So right now I have it in the fast forward mode, just to make the time catch up. So it's still got about, well, it's an hour behind right now, so I could just leave it like this. There is obviously a much faster way to fast forward. That's just to manually move this thing here. And that will fast forward this thing, so I think I'm gonna do that for now. And then for the last bit, we'll just let this clock run up, because if you do it manually, you might end up with the issue where it gets the polarity reversed, so the next time this sends a signal, this arm will already be in that position, and therefore no signal will be sent. So yeah, that could be an issue. And there we go. You can turn that off, and it's now showing the correct time. I also had to put a little, just a little washer kind of behind this plate here. I can probably see it under there. It's just sticking out. The reason was it didn't fully close the second contact, so it was a little too far off, but now it all works. And let's see if a signal will be sent when it reaches. Oh, that was strange. It sent the signal before reaching that. How strange. Huh. Alright, let's see. Let's wait another minute and see what happens. Coming up on the next signal, and there we go. It shifted. So that's about it as far as these clocks go. If you have any questions, put them in the comments, of course. Other than that, I'll see you in the next video. Until then, have fun and stay safe.